A very good morning to one and all. With the blessings of the Almighty and our beloved founder Chancellor, Colonel Dr. J.P.R. Sir, we've all gathered here virtually for celebrating the World Water Day, organized by the Center for Ocean Research, jointly with the Center for Remote Sensing and Geoinformatics and Department of Civil Engineering in association with Earth Science and Technology Cell, Ministry of Earth Sciences, and with the IUCN Commission on Ecosystem Management. On behalf of the Center for Ocean Research, I take a moment to express my heartfelt gratitude to our patrons and our higher management, Sathyabama Institute of Science and Technology, for their constant guidance, support, and encouragement in all our activities. Now, it's time to get into our technical session for the day. Today, we have with us Dr. Muthukumar Muthuchamy, Professor and Head, Department of Environmental Science, School of Earth Science Systems, Central University of Kerala. Before getting into the technical session for the day, I would like to introduce our speaker today. Professor Dr. Muthukumar Muthuchamy, currently Dean, School of Earth Science Systems, Head, Department of Environmental Science, Central University of Kerala, is also a Chief Vigilance Officer. He received his PhD degree from Anna University, Chennai, India. He served as an assistant professor in the Department of Environmental Sciences at Bharatiya University, Coimbatore, for more than a decade, and joined as an associate professor and subsequently joined as a professor in the Department of Environmental Science, Central University of Kerala, Kasaragod. For the past 20 years of his research career, he has been doing research in the areas of water and wastewater treatment, sludge reduction process, microbial fuel cells, climate change and adaptation studies. He has also received projects from various funding agencies such as DRDO, UGC, DST, BRNS, etc. He has published more than 85 research articles in the reputed journals. He has guided 13 PhD theses, 6 MPhil theses, and 52 MSc dissertations. Presently, his team is doing research in the area of climate change and adaptation studies in collaboration with the Institute of Bioecosciences, MD, USA, for the Western Ghats biodiversity conservation and the production of energy from solar and wind in collaboration with Sokoto Energy Center, Usmanu, Danfodio University, Nigeria. Apart from this, his team is also doing research in the preparation of nanocatalyst from rare earth metals for the electro-oxidation studies in collaboration with the University of Concepcion, Chile, Latin America. We are pleased to have you with us today, sir. Over to you, sir, for the technical session.
Thank you, initially, for the introduction.
Thank you, sir.
I wish to thank Inbakandan for inviting me to share some of the ideas of, or I can say the what I learned from water since the past 25 years I'm working on in the field of water research, and we are doing some work, application-oriented work, especially for the society. Application-oriented work which we are doing it. And, out of which one small part I thought of wanted to share you, because since it is a faculty development program, so that the faculty may grasp or you can implement it in your home technology. What I'm going to discuss with you. That's what I thought about it. So in this function, I thank Dr. Inbakandan for inviting me, and also I thank Professor Utilization ma'am, who was head of the Department of Civil Engineering. Also, I thank other authorities for inviting me to share knowledge. So, as they say,
thank you. Sorry for the interruption, sir. Your voice is not audible. Sir.
Yeah. Is it okay? Is it clear now?
Yes, sir.
Yes, sir. Yes, sir. Now it's okay.
So today I'm going to discuss about the sustainable utilization of water. As a part of the World Water Day celebration 2022, I think the Sathyabama Institute has organized a faculty development program on sustainability, conservation, and protection of water resources. One of the important area, and we may have to think of it because being in Chennai and we are already facing a lot of water scarcity and water stress, all kind of problems we are doing it. So as a educationist or as an environmentalist, we may have to aware of what is going on here about water. That is why we have been celebrating even the World Water Day being celebrated since from 1993. Probably this is the fourth day election. You might be heard it a lot about World Water Day celebration. I don't want to repeat it. But the theme of this year has been given as a groundwater, making invisible visible. That's what the theme has been given. So I wanted to make a the thing is that what technology is, even though it is there, we want to make it as visible. Okay, all right. So even our department also, our institution also has celebrated the World Water Day on 22nd March. Okay, Tuesday during the first day of your active program, and a small actions fund we have been initiated. For example, we have been given a water pot to all the students. We have been separated and we have been placed in the campus. Actually, our campus is a 320 acres campus. So we have been, because now it's a hot summer. Okay, not like Chennai. Chennai probably May is a hot summer. May and June will be the hot summer, but here March and April will be the hot summer. So we thought of making use of this simple technology only. We are placing the water pot into throughout the campus so that the host recipients will get benefited. It's a small action, but certainly change the life of the others. So likewise, we may have to think of it. Right. When we talk about my topic on excuse me.
And what happened, sir? Any technical issue?
Sir, please tell me, sir.
Network issue is from my side or your side, sir? I think my side. I believe. Oh, sorry. I don't know. I'll check.
Dear participants, sorry for the interruption. There is some internet issues from the speaker side, so he will join shortly. Thanks for your patience.
Please enable.
Yeah, I will. I'm making us of course. Try now, sir.
Is it
The
visible?
PPT is visible, but you have to go to the slideshow. Yes, sir. Now it is in the slideshow. No?
Is it okay,
You can
sir?
go ahead. Sir. Yes, sir. You can go ahead, sir.
Oh, sorry. Okay, some network issue in my.
It's everywhere, sir. No issues.
It's a drawback of the online program. We're also facing every time, right? So, as I said, we have celebrated, okay, and we have placed many pots throughout the campus. Okay, as I said, it's a small action, but certainly the small action will change the life of others, right? Okay, anyway, coming to the topic, what I want to discuss is sustainable utilization of water. Probably this is the fourth day of exercise, and you might have heard a lot more about water, right? So when we talk about water, when we feel the water, certainly we may feel the symbol of devotion and purity, right? Even when you visit any of the places like the ocean, you see it nearby, when you go to beach, if you get excited, or you go to waterfalls, or in the lake or pond, whatever it is, wherever you go, when you see the water, you feel excited, right? The positive vibrations. So that's what it says is as a symbol of devotion and purity. Right? And also, even you can see the history, the human settlement, right? Wherever the water facilities are there only the human settlement was happening. Okay. In many places, almost all the earlier histories you can look out the literatures, you can easily find out. And also, many of what to say, medicines are mainly following water therapy based on that one. Okay. And also the many healings of springs. Okay, springs are located all around the world where the people are taking and healing diseases. Okay, so it clearly indicates that the importance of water. Right? So even when you talk about our body as an adult, what we have is approximately 42 liters of water in our body. Okay, 42 liters in each adult has, and in which there are 2.7 liters. Okay, if you lost it, certainly it induces, make you to suffer like a dehydration or symptoms like irritability or fatigue and nervousness, dizziness, all these things. That is why the doctors are, the health professionals are insisting you to take minimum 2.5 liters per day. Okay, this is the reason. Okay, you should not lose your water fluids, okay, water from your body. Okay, and otherwise, ultimately, it causes a lot of numerous problems in it. So this water availability, probably even from my school days, our school days, we are discussing about it. Okay, 97% of water is available in sea and 3% is available in surface. Okay, that's what we have been discussing it. And 2.5% in the glaciers. Okay, so frozen water, you're not able to use it. Only 0.5 when you use it. So even the 0.5%, right? Many of the waters are available in the groundwaters. Right? That's why even this year theme was given as making invisible visible, because we are not able to see the groundwater. We normally the water will be classified as the groundwater as a green water, right? Blue water, green water, black water, gray water. Probably you might have studied or maybe heard. So this green water is a groundwater. Okay, all located under the soil. Probably it's some aquifers where we can take out the waters. Okay. Right. So unfortunately, this groundwater is getting polluted due to numerous reasons, and we're not able to use it. Okay. Even water recharging, water recharging, everything has been failed because of that reasons. Only this year they have been insisting upon us to go for aware of making you aware of the groundwater utilizations. Okay. So this is a simple calculations I taken from the website, how per day consumption of water per person, okay, or per capita, whatever it is. So probably we're using for drinking 5 liters approximately. Okay, it's not exact liters. This is what it has been given. 5 liters, or bathing 55 liters, cloth washing 20 liters. It has been given, and house washing. Sorry, this okay, ultimately 135 liters per day per capita consumption is over the consumptions. Okay. So where we are using it, 35 liters, as I said, approximately for toilet we are using 26.8% of water, and clothing, washing, approximately 21.7%, and shower 16.7%, or you can keep, especially for the leaks in the pipelines, that's 13.7%. Okay, this is not pertaining to India, but it is pertaining to global testing given by the analysis foundation. Right. So where we are meeting out the water demands, right? So for example, 12% of the water demand will be met by open well, 80% from borewell, that is hand pump water, and 16% from mini water supply where the municipality or pipe water they use. Okay. And 25% from public tap, and 2% from the field. This is what has been. So, and this just I thought I wanted to show you, because this is also we study from school days, water cycle, right? Evaporation, condensation, precipitation. Okay, it is a cycle. So why I place it here, and because whatever the water is available here, it's get evaporated and condensed, then as a precipitation is coming back to the earth. Okay, if that is the case, okay, it is water cycle. That is the case. Why there is a shortage of water, right? See, all the resources institute has projected in 2025, but we are going to face the water scarcity. Okay, whatever water is available is evaporated, and condensation and by precipitation is coming back to the earth. There's a cycle. Then why this scarcity has been taken place? Why what is scarcity? Right. So according to the FAO, it just clearly says that water scarcity is either lack of enough water, means a quantity, okay, because as I said, 135 liters per person, or normally what they're calculating is 1,700 cubic meter per person per year. Okay, per annum consumption is 1,700 cubic meter. If it is less than that, obviously it is they may be calculating as a water scarcity. Okay. And also this is lack of access to safe water, lack of access to safe water, this quality of the water. Okay, clearly it's mentioned that around 2.8 billion people around the world, okay, throughout all the continents, at least 1 month out of every year, and more than 1.2 billion people lack the access to clean drinking water. Obviously, because during the summer, probably all the cities are facing a lot of problems to meet our daily usage of the water. Okay. So, and also the statistics says 1 billion, nearly 1/6 of world's population are already facing the shortage of daily basis. Yes, obviously, especially the Sahara regions. Okay, they are facing a lot of problems. So the another statistics, according to the United Nations Food and Agriculture Organization, it states that 2025, 1.9 billion people will be living in the countries or the regions with absolute water scarcity. Okay, and 2/3 of the world population will be under stress conditions. That's what this clearly indicates. So water scarcity or water stress, as I said, the availability of water. Okay, the availability of water 1,700 cubic meter per person per annum. That's what it says. Okay, if the water is less than 1,700 cubic meter, then obviously we are facing water scarcity, and because of that scarcity, we are facing stress. Okay, we are reducing our usage. Okay, that's what it says. So approximately 780 million people lack access to clean water during 2025. The other statistics clearly mentioned. inadequate access to safe drinking water for about 884 million people. Okay, and also see the main reason is because of the population. Okay, population to threefold, but water demand go to sixfold. So that's what you say. Okay, because when the population increases, the demand has to increases as of sixfold. And also it is clearly mentioned that during 2025, the World Resource Institute has been projected that 54% of India is going to face high to extremely high water stresses. High to extremely high water stresses. And this is what has been clearly mentioned. So, obviously, you might be seen in the newspapers where the water scarcity or stresses makes the people to get water, plenty of. So demand is very high because of the population. It's also come out in the papers. Okay, and even people are thinking that in another 100 years there's going to be a third world war may come because of water, right? Someone would say so. Okay, so because of that, the Millennium Declaration has been insisted upon to stop the unsustainable exploitation of water resources. It's clearly mentioning it. Stop to unsustainable exploitation of water resources by developing water management strategies either in a regional level, a national level, or local level, which promotes both equitable access and adequate supplies. Okay, this Millennium Declaration has been 8 goals has been given, and unfortunately, the declaration was not reached to throughout the world population. So they made it as a sustainable development goals. They really coined the word, and also they have been made some targets, right? And almost I can say 17 sustainable development they introduced. Okay, they renamed as a Millennium Declaration. Okay, instead of that, then they made it as a sustainable development goals. So the number 6 says water and the sanitation for all. Okay, that's what it insisted. Okay, you have to provide. We wanted to remove hunger. Okay, by providing a safe drinking water to all the world. Okay, that's what it's insisted upon. Okay, why this is happening? Why this is unsustainable exploitation of water resources? Unfortunately, there are main reasons I have been given here: demand and usage, supply, climate change, population, and pollution. These are the main reasons for it. Demand and usage. Okay, I think on the right side I have given some pictures of want and needs. Okay, so the wants, we need actually wants is uh, one tumbler of water is needed. Okay, but unfortunately, we need more. Okay, we are expecting more. That is what the demand has increases. As I said, the population increases threefold. Okay, the demand has increased to sixfold. Okay, so the needs are increasing more rather than the wants. Okay, and the supply, you're not able to supply it properly. Okay, throughout all the populations, and that's mainly because of the lack of water. Okay, and the climate change is one of the factors, main factors, which everyone is discussing about it nowadays. Okay, how to control it, how to reduce the carbon emissions. Okay, actions oriented. Everything is talking about sustainable development goals. Okay, and the population obviously it is increasing, and since it is population increases, all the demands, not only the water, okay, even energy or other commodities demands are increasing to meet out water we use. Okay. Unfortunately, the pollution is also one of the main contributors because of the pollutant, okay, which is destroys our all the water bodies. Okay, so these are the main causes for the scarcity of the water. Okay. And these are the pictures are taken for to show it. Okay, in future, certainly after 100 years, okay, all the rivers will dry. Okay, the situation goes like this: all the rivers may dry, and all the pond and the lake is also going to dry up. Why this is happening? Because see this data, statistical data, by the United Water Nations Water Development Report has been given us. The lower income countries, they use water for the industrial purposes only 10% approximately. Okay, but whereas in the high income countries, they are using 59%. Okay, but whereas for agriculture purpose, the low income countries they use 82%, whereas the high income countries they use only 30%. So here I want to stress upon you that industrial usage of water results in the generation of wastewater. Generation of wastewater. Okay. And this is picture shows that in India, okay, it is different sectors where the demand is right. So in agriculture, because being in developing countries and we mainly based on agriculture resources, what we are using is 688 billion cubic meters in 2010, and it has been projected in 2025 as 910, and probably in 2050 it is going to be 1072 billion cubic meter of water is needed. Okay, and also see, think of it, the drinking water has doubled. Okay, it's going to be 56 billion cubic meter in 2010, and in 2050 is going to be 102 billion cubic meters. Okay, obviously, this is because of increasing population, and also the industrial usage also increasing in India. Okay. So the energy and other sectors also it has been given. It also everything it is increasing in the futures, right? So as I said, the industries are using the waters and generates a huge amount of wastewater. Right. This is some example. Just I'm given as statistics have been given. Okay, for like thermal power plants or engineering or paper and pulp industries or textiles or whatever it is. Okay, so how much quantity of water they have been consuming and they have been sending out as a waste to water. So this waste to water, if it is not properly treated, then automatically. And this is, has been this data recently has been taken and shows that the polluting industries discharging effluents directly into the lakes or rivers in India. Okay, it has been state-wise, it has been given. Okay, it has been clearly it is mentioned that a number of industries, how many industries are directly polluting to the water bodies. Like Uttar Pradesh is the first one. 1,648 industries are they are using and they are discharging wastewater directly into the lakes and rivers. Okay, right. And also because of the discharge of the wastewaters and the number of cities, okay, in India is getting polluted because of the pollutant like nitrate or iron or fluoride or arsenic. This data also shows that in India, approximately 387 districts are polluted with nitrate. Okay, I think probably you might be knowing it. If the concentration of nitrate is more than 40 ppm or 40 milligrams per liter, it induces the blue baby syndrome, especially for the in baby, blue baby syndrome probably. Right? And 297 cities are facing the iron content is very high. Okay, and also fluoride and 276 districts, and even arsenic for 68 districts. Okay, it is mainly because of not only because of the soil structure and also the what to say the discharge of the wastewater from the industries. It also contributes for the. So this data is taken from the Central Pollution Board. Okay, it shows that wastewater generated from the households as a sewage water generations, right? So, see, in this table, it is clearly mentioned that the wastewater generation, as we are talking about only urban population, because in the rural areas, they do not collect the wastewater and discharge it, or simply they discharge or into the land itself. Okay, only the urban city only we're talking about urban populations. Okay, for example, in 2021, there are approximately 490 people, millions. Okay, so if you calculate 135 liters consumption is per day, per capita consumption is 135 liters. So the wastewater generated is 65,880 million liters per day generation, wastewater generation. You see, and even when we assume 121 liters per day per person, see the wastewater generation. Okay, it's huge. So when we use this wastewater generated from our household, when we utilize it wisely, certainly, what we can say, we can save the water, right? We have to think of it, right? See, the wastewater generated in 2031, we are going to generate 77,198 million liters of water per day. Okay, each day we are going to generate it, right? If you are not handle it, so because of the reasons, this other statistics clearly says that 1 out of every 4 deaths under the age of 5 worldwide is due to the water-related diseases. Okay, because of untreated waters, and 80% of the illness caused by unsafe water and sanitation because of poor sanitation in the world. Okay, it also clearly says that. And also even the rural people, the rural communities are poor people in our rural areas. Okay, so they are walking for long distances to fetch the water. Okay, right. So this all making us to think of it, what we are doing. Obviously, there are a lot of challenges out there. Okay, when you want to develop a sustainable resource management, especially for the water utilization side, right? So we have to think of supply of safe water and sanitation. We have to provide proper sanitation. That's what even we are looking for it. Okay, SDGs, the Sustainable Development Goals 6 clearly insisted upon water and sanitation for all. For all, you may have to provide it. And also you have to provide a water for agriculture and industry. You have to give sufficient water because we need a development. That's what we are looking for it, right? To meet out our demands, right? Whatever it is, right? So we may have to give water and manage available water supply and use whatever the water is available, how to use it in a wise manner and provide trained personnel. Okay, these are the challenges we are facing even for the water treatment plants. You can see it. Okay, there's no trained personnel because of that water inefficiency with the water treatment processes. Okay, and also we have to promote institutional development or provide infantry academic development. We have to make aware or develop professionals in the academic institutions so that they will help us to resolve the issues. Okay. And promote governance and legal structures. We have to change the policies. Okay. These are the challenges when we wanted to to resources and we wanted to manage the resources. Okay, and even the United Nations has been given the report in 2016. You can consider the water as a jobs market. Someone nowadays all everywhere the bottled waters are available. Okay, they're using it. Okay, it's a great market nowadays. Since the demand of water is increasing, right? So you have to create jobs. Okay, in the water sectors is what it has included. Okay, now coming to the sustainable water resource management. As I said, the water generated from the households or from the wastewater generated every day is increasing. So how we have to manage sustainable manner? That's what it says. Okay, the sustainable water resources management is a process which promotes the coordinated development and the management of water, land, and related resources in order to maximize the resultant economic and social welfare in equitable manner. That is very, very important. Okay, that is what even SDG has clearly insisted upon it in the SDG 6. It says that water and sanitation for all, it is clearly mentioned. Even equitable. Okay, you have to see even from poor to the rich. Okay, everyone has to be attained in the world, and without compromising the sustainability of vital ecosystems. Okay, we should not damage the ecosystems without changing it, and we have to meet out. Okay, that is what the sustainable water resource management system. Here, I would like to give you one small example. Okay, we are doing it. So, this is mainly for the domestic wastewaters, okay, generated from the households. So this worldwide, 90% of the human excrements and urine go to rivers, lakes, and to the sea, or the groundwater instead of being used for improving soil fertility. Okay, that's what we have been doing it, right? Almost 90% of the wastewater. There's no separate treatment. Only 10% of the excrements, okay, human excrements will be used for the treatment processes. Right? So this is called the shortcomings of the conventional water systems. Okay, because of this shortcomings, okay, when we are not able to treat the 90% of the waste, the excrement, okay, it is get contaminated into the river bodies. Normally, it is contaminated through sewage. Okay, because the sewage plant, they are not doing it directly discharging into the water streams, and all the water, natural water bodies getting polluted. Because of that. Right, all the contamination. Okay, as I said, scarcity. Even though the water is available, right, in the water cycle, what I was insisting upon it. Even though the water cycle, the water is available, it is not safe water. Water is available, but we are not able to drink, or we are not able to use it for any other purposes. So that is because of this. Normally, what we are doing. So when you think of it, when you applying the sustainable water management by segregating the water from the source itself, probably we may have to achieve it. Achieve the sustainable resource management. So how we have to do it? So the aim of the sustainable water management is to reduce the water pollution and the sewage, okay, generation of sewage. Okay, because we can use it, we can reuse the water from our household itself instead of discharging, okay, exposing outside of the premises. Saving of scarce and expensive drinking water, obviously, because we are paying nowadays. Okay, we are paying, getting 1 liter water is minimum 15 rupees, 15 to 20 rupees we are paying, we are getting it. Okay, and using grey and rainwater, so you have to think of it how the grey water will be. Okay, water used in the households for washing, or what you can say, okay, the waste come out. So the wastewater generated from the grey water, we call it as a grey water. Okay, and also rain harvesting nowadays is insisted. Even in Tamil Nadu, it has been insisted whenever we construct a house, compulsorily we have to do it. Everyone knows that. Okay, so they are what to say, the importance of rainwater harvesting system, especially in Kerala. We have almost 6 months we have water, rainwater. So we can collect a huge amount of water. Okay, so and cleaning wastewater by natural processes. That's what it's insisted. Okay, the sustainable water management is by natural process itself. Okay, why we have to create a wetlands? Why we have to make a land? Okay, so it will automatically, whatever the pollutant is there, it automatically treats by natural processes. And recycling nutrients to agriculture for soil fertility. Okay, how we can utilize, okay, our composting, or how the organic matter be converted into compost, and we can use it for agricultural purposes, or possible wherever possible we can generate energy, okay, biomass or energy production. That's what mainly the sustainable water management insisting upon. Okay, so right. So here I was to there are 4 steps are there in the households, how we can recycle the water. Use it wherever possible. We can apply this. Okay, so there are 4 steps, as I said. So first step, what it says, reduce sewage streams by saving water. Why you can reduce the generation of sewage water, that means sending out of your compound or your premises. Okay, how we have to do it? Right. For example, every day approximately 20 to 100 liters of rainwater we are generating it. Okay, or even fresh water. Okay, when you are using it 500 ml of urine. Okay, you are flushing out, right? Every day, minimum 6 to 25 liters of water has been using it. And every day we are approximately 50% has been generated. Okay, so when we think of this grey water and urine or the feces as a material, raw material, and we can use it for purposes. Okay, in order to reduce the water generated, for example, when the grey water and urinated water and even the feces are contaminated, all sending to the tank, and the same water is sending to the sewage water. Okay, all the water gets contaminated. Right? And now I think probably we all know that. Okay, nowadays the vacuum toilet has come. Right? In the earlier, okay, when you flush it out, approximately 8 to 12 liters of water each flush out. Right? And nowadays, it's been because of the advancement of the vacuum toilet, it consumes 0.5 to 1.5 liters in every flush. Okay, every flush. So we are at least we are conserving the water. Okay, and we're not wasting the water also. Try to implement okay, in future when you construct a house, new house. Okay, or existing system you want to replace it and you can use it for conserving this toilet. Okay. The main advantages, as I said, it is lower water consumption, certainly, and also effective collection of sewage, and not more operational problems than conventional flush toilets. It's very easy to operate and high acceptance by the residents. Okay, nowadays, many of the residents are new constructed using this vacuum toilet. Okay. And also the pipelines when you are connecting it okay, to the toilet. Right? So if it is a larger in size, okay, pipelines, the velocity certainly is going to be less. Okay, if the volume, the diameter of the pipe is less, the volume will be very high. Okay, the flow volume will be very high, and pressure. Okay, so try to change the diameter of the pipe in the connection circuit, right? And also try to make use of this dual flush toilet systems. Okay, that certainly it will conserve your water from the households. So the second step is to separate the sewage streams, whatever the wastewater generated from the houses, like a grey water or urine or the excrement. Okay, try to separate it out. Okay, you should not make it as together, so automatically the whole water will get contaminated. If you segregate it separately, like a grey water separately, you can take it out, and urine you take it out separately, or excrement is taken away separately and do a treatment processes, and obviously it will be going to get a benefit of it. Okay, like grey water in the house, simply you can put it back. Okay, so whatever the water is come out, you take it out, or you can simply you make a tank water. Okay, where you can storage tank, collection tank, call it as, to store the water, and overflow water will be taken. Even you can put a sand filter or even gravel filter, you put it and take it out, and directly you can use it for the irrigation purposes. Okay, it's very simple methods, nothing cost anything. Okay, and it is certainly it will help you for conserving the water resources. Okay, or see the picture screen is given. Okay, wherever the toilet okay excrement is there, all right, or urine is there, you taken as a yellow storage, and the excrements is taken as the water block water is call it as, and also the grey water. Okay, for sure, whatever possible, we take it as a grey water separately. You use it for grey water treatment, simple collection tank, overflow water taken to the either the gravel or sand filtration, and filtered water taken for gardening purposes. Simply you can take it out, and you can take this yellow water, urine water, and properly can handle it, because what to say, the urine contains fertilizers. Uric acid is the urea. Okay, you can relate it, and see this the black water. Why we have to make it a separate? Because when you join together in the grey water, the whole water is going to be contaminated. It's very difficult to remove it. So if the segregation is very important steps for treatment. And the third step, close the nutrient cycle with the blocked water. That's what it says, right? So the statistic says each person annually per annum discharges the excrement, nitrogen about 4.5 kilogram, and phosphorus about 0.5 kilogram, and organic matter about 35 grams. So totally 40 kg of nutrients what we generate every person. So when we segregate it, okay, we can use it as a fertilizer. We can use it as a fertilizer. Properly, we may have to use it. For example, it says urine and excrements matter contain low level of heavy metals. Certainly, the nomination will be very less. Okay, only thing you have to handle it properly, and certainly you can use fertilizer, and which we can use it as a soil fertility, to enhancing soil fertility, or even the fishes has been taken to the biogas generation and digest it, take out the energy and use it for any other purposes, fuel, or as well as even you can use it for lighting up. And the digested sludge, you can take it for composting and use it for as a fertilizer. This is what it says, closing the loop. Okay, closing the loop. Right. So whatever the experiment will be generated, okay, you put it to the composting, right, or biogas, or the generation of biogas, you can put it in the composting, where you can kill all the microorganisms, and once it's composted, it becomes a nutrients. The nutrients will be used for plant growth, and you can generate a food, then you can use the same food, you can use it. Okay, this is what it's called closing the loop. Okay, it's a cycle, right? You can easily do it in itself, and if you feel that we generate energy, okay, the fishes and urine also combine together, we can take it out separately. Maybe septic tank will be there from there, and even with the help of what to say, the houses, whatever the waste generated after food waste, everything, that also you can join together, combine together, and we can generate biogas production. Even nowadays, many of the hostels, especially for the institutions, the hostels are using the generating biogas plants. They are using it, okay, for generating the. It is an old concept, but now it is generating it. Nowadays, it's coming popular. Okay, and they're using for the energy purposes. Okay, gases. And obviously, these sludges, digested sludge, you can take it for compost and use it for it. As I said, you can close the loop for reducing it, utilizing it. And last step, fourth step, the gray water. Okay, as I said, the gray water, you can take it, you can construct a small tank. It's called collection tank, as I said, to overflow water, because this is what I have done it in my home. Okay, it's what I'm using it every day in my home, and the water come out from the tank, and we use it for directly and passing it to the my garden. So this is what I say, gray water, whatever the gray water, because approximately 100 liters of water will be generated every day, because the population is 4 or 5 members in the family. Okay, minimum 100 liters will come out. Okay, that you can very simple technique. Just collection tank is there, overflow water will be taken to the filtration, either gravel or sand filtration. You get. But I have adapted a gravel as well as sand, both using it. And the gravel filtration, like a trickling filter, just I'm opening it for the sunlight, so that if any organic compound anything is there, so that it get degraded. And the overflow water again I'm taking into the sand filtration, and the water will be taken for the gardening purposes. Okay, so this is the very much useful technology. I always say the reuse of the water. Okay, so when you do like this, okay, when you adapt any one of the methods in your household itself, okay, certainly we will have to utilize it. That's what it says. Even the cities where normally you might have seen it. Okay, they develop wetland areas where they cultivate the biomass, and biomass will be taken out for what is it, either for energy sources, or they will compost it, or even nowadays people are using as a building material. Okay, so the sustainable water management certainly will offer the economic decentralized solution for a good water future. So that's what I want to insist upon it. Okay, so decentralized solution, you can do it in your house itself, instead of blaming the municipality, or blaming the panchayat, or whatever it is. I won't say anything on it. Okay, this plant is not working, and we are simply discharging the water body is contaminated. Instead of it, you make it as a decentralized solution. You can do it from your home itself. Okay, try to reuse it. Okay, so when you do it, certainly this techniques is going to be one of the best method for conserving, or we can say that we can use the water in sustainable manner. Okay, so I think with this, I thank you, on and on, for listening my lectures. Thank you all.
Thank you, sir. The session is now open for queries.
Thank you, sir.
Thank you, sir. It is very wonderful presentation with more information. Thank you.
Actually, I'm sorry, I didn't put on any research in it because I don't want to.
Sir, this kind of presentation only it is needed, sir. If we are going for more of a research means you have given the nutshell in a nutshell format. What are the concepts we have to adapt it to save the water? So it's very nice one.
If that awareness, if we can import automatically, research things will come automatically.
Definitely, definitely.
Yes, ma'am. Yes, ma'am. Simple actions only, ma'am, but certainly it will change your life. Because I'm experiencing my house, that is why I'm saying. So I adapted this. I'm proud to say that what I taught in the class, I adapted in my home. Please say.
That sustainable water management, these big words should start from individual level, that is the family level, and then next to society level, then only. We are talking, but individuals like us, we need to implement.
So, Muthukumar sir, I have a question. So, what is your suggestion on the seepage of salinity in the groundwater?
Sorry, what is your
So, the salinization of the groundwater.
salinity? Yeah.
Yeah.
No, this is mainly because of the groundwater, unsustainable utilization of groundwater, I can say that. Because you are taking out more and more water, especially for the Chennai city. And just an example, I'm saying that. Okay, during 96, 97, when I was in Anna University, you can see very few apartments. Okay, and nowadays till Sengalpattu, it has become a city, right? I'm surprised. Many apartments, and all the apartments are depends on the groundwaters. You are extracting more and more amount of waters, and unfortunately, the recharging is very less. Because obviously, since we are very close to the what to say, the sea area, sea coastal area, so the saline intrusion will be there, sir, more and more. Okay, so now the solution, I cannot say this is a concrete solution, but we have to reduce the utilization of groundwater. We'll try to use the surface water, and whenever the rainwater comes, we may have to recharge the ground, sir, flush out the ground. That's what I can say, so that at least further intrusion will be stopped.
So unfortunately, we are all living in the concrete forest, and definitely we have to suck all the groundwater. As even yesterday also, I have highlighted this comment. We have to go for a rainwater harvest even in all apartments. But apart from that, it is already done. So if there is any other suggestion, so even though we are implementing this rainwater harvest also, already some of the even our campus, Sathyabama campus, we have the groundwater in the saline area, and behind that I am living in the Perimbakam, when we have the same kind of water, saline water, when the groundwater is very they have a salt content. So there is any other solution other than this aquifers or rainwater harvesting things and all?
Yes, sir. Sir, I'm also having the same thing. In Sathyabama campus, we have a clay soil, and the water table is also very near to the ground surface. So if that is the case, how we can? So as we know, our rainfall, annual average rainfall is 900 to 1,100 more. But the rainy days are very short period. That's why we couldn't harness the entire that rainfall water. And moreover, under the ground, the soil is also not helping us to store. So if that is the case, water table is also very high, very near to that. How we can do or construct that rainwater harvesting under the ground? Any modifications, anything from your side?
Actually, as per my knowledge, even the Chief Minister Jayalalitha Madam has introduced this concept compulsory in Tamil Nadu, and till now it is only for paperwork. I'm very sorry to say. We will show in the because when we get approval from the building approval, we will show we are going to do this harvesting. And even after the construction over, we will show it smallly, and then we never bother about whether it is recharging or not. That is the problem. One thing. And second thing, because already we are in the verge of the climate change. So, as you said earlier, the monsoon pattern is different. Nowadays, even though we are getting 1,100 mm per annum, within short period, only a week.
Yes, sir. Yes, sir.
Here normally used to get a 3 months duration. Now we are getting in 3 days. That is the problem. Actually, what to say? It is mainly because of the climate change. Okay, the carbon emission you can say is global warming. Okay, back you have to come back like that. So it is our responsibility to reduce the carbon emission. To reduce.
Create more green spaces.
Madam.
Create more green spaces.
Yes,
So that we can balance the imbalance.
For carbon sequestration, when you talk about it, okay, so it will absorb. That's what we are teaching them. Okay, we have to plant more trees so that the emission, but still the population increases, the demand is increases. That is the problem. Okay, as I said, the want and needs. Even during the Paris Agreement, India has come out from the protocol. They not signed it. 2002. Mainly the reason what they said is wants and needs. That is the argument has come. Okay, they want us all to stop eating rice, paddy cultivation. They wanted to stop it, but in India, almost 90% of people depends on rice. Right? Our food habit is okay. That is why we come out. But unfortunately, the developed countries, they are for their sophistication, they are generating huge amount of energy, carbon emissions, very high compared with developing countries. But they are not bothered about other things. They are asking us to curtail the paddy cultivation because of the wetland, which generates a huge amount of greenhouse gases or methane or something they're talking about. The recent 2015 Paris Agreement, what you say is we should not go beyond Celsius. That's what we're targeting it. Unfortunately, we are going to touch 1.5 degrees Celsius. The global warming temperature is going to be very soon. Okay, we are preventing it, but because of the demand, okay, what the population increases, the demand also increases. Obviously, they are taking steps to increasing the carbon emission. That we have to freeze it. That we have to. Then only we can do it. Otherwise, we cannot. Regarding the water recharging. Probably, as we said, if you have campus, you will have the water recharging. Try to create some pond, small pond area. Is it possible? Because the campus is very small, I don't know whether it is possible to make it. If you have a small wetland or ponds like systems, you make as a what do you say, the just to small area.
Yes, sir. Yes, sir. Yes, sir. That is possible.
I think it's
like artificial wetland.
And,
but actually, the soil is a continuation of the wetland, particularly natural wetland only. If we are creating some engineered wetland, it will be for landscaping purpose also, it will be very good.
Yes, ma'am. That we can do it, ma'am. Because instead of recharge also you can do it. You can store it at water and make us like a park. You can make a aesthetic. You can develop it and you can store it. I think Sathyabama Institute is in a low-lying area.
Yes, yes. That level is equal to mean sea level. Most of the places in our campus equal to mean sea level, the surface.
So that kind of when you do it, some engineering way to make a pond, so our wetland, you can create it. Probably you can store the water.
Thank you, sir. Thanks for the information. And any other questions from the participant?
No, sir, there are no questions in the chat box.
If there is no questions in the chat box, it's very nice. Thank you, Muthukumar sir. Thanks for your presentation and thanks for the answer from both of us, as well as from myself, as well as Pakalashmi ma'am. So soon I want to have a more discussion with you, and we will write to you, sir. And if possible, when you are coming to Chennai, please visit our campus.
Yes, sir. Sure.
Thank you.
Thank you, sir. Thank you very much for the informative session, sir. You highlighted not only about the scarcity we are about to enter, but you also highlighted the challenges that people are facing in the rural areas. And also, thanks for bringing out to us the different strategies we can employ in sustainable water management. Thank you very much, sir. It was a very
Thank you.
interesting session. Thank you, sir.
Thank you, Ms. Bhuvaneshwari.
It's-
Bhuvaneshwari, now you have to tell about the tomorrow session.
Sure, sir. Once
Yeah.
again.
Thank you, sir.
Thank you, sir. Thanks, Muthukumar, sir. Thanks a lot, sir. Please join us tomorrow also, sir. We have a valedictory function,
Sure, sure.
and our director research is going to join on the session, sir.
I will join. Surely I will join, sir, tomorrow.
Thank you, sir. Thank you. Thank you.
Thank you, sir. Thank you, sir.
Make
Thank
me
you.
co-host, share the tomorrow's schedule, sir.
Yeah.
Thank you. Thank you.
Vineet, you said something. I'm unable to.
Sir, please make me co-host so that I can share the tomorrow's schedule, sir.
Schedule details, sir.
Please make me co-host, sir. Yeah, thank you, sir. Thank you, sir. Is it visible now?
I don't think I will share the.
Okay.
Is it visible now?
Yes, sir. Yes, sir. Dear participants, kindly note that we are entering into the last session on 26th of March 2022 from 10:15 a.m. The details of the session is that we have a guest speaker for tomorrow, Dr. Gagan Matha, Senior Assistant Professor, Department of Environmental Science, Gurukula Kangri University, and he'll be delivering a lecture on water conservation through science communication under Sustainable Development Goal 6. Kindly note down the link, which has also been sent to you through mail. Thank you.
And one more announcement, there will be a feedback form will be distributed to the participant in between the session or after the session. Those who are submitting fill the feedback form, they will get the certificates. Thank you.
Thank you.